The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees.
Thank you so much for having us here. I'll be presenting on behalf of Professor Mohsen Isa from University of Illinois at Chicago. He wasn't able to be here today. So I'll be talking about the effect of early opening to traffic on the fracture mechanics parameters of the IDOT concrete pavement mix designs. In general, as a quick introduction for the topic, there are plenty of challenges that is associated with Portland cement pavements, especially at the stage of early opening to traffic. These challenges can range between traffic congestion due to closures, economy due to the time delays and time wasted due to the construction and the time that we need to wait to open a pavement for traffic, fatigue damage, that we still have a problem in identifying and quantifying the fatigue damage at early opening to traffic, especially when the criteria for opening to traffic at IDOT is mostly based on hardened properties, which is mostly the compressive strength of the concrete. And most of the design parameters that are taken into consideration in the design of the pavements is mainly also hardened properties. However, we still do not take into consideration the effect of the stiffness degradation at very early opening to traffic, very early age of early opening to traffic. And when we say very early age, we're talking about 12 hours, 1 day, and 2 days, and 3 days. The current specification is mainly focused on strength, as I mentioned. And for example, for PV pavement mix designs, I'm going to go over them in a little bit. The criteria for opening to traffic is compressive strength exceeding 3,500 psi. And it will be also covered, part of it in the next presentation, showed that we can also add into these parameters another parameter such as the effect of stiffness degradation due to early loading at early age of the concrete pavement. The objective of this study is to characterize the fracture parameters describing the crack initiation mechanism, the stiffness degradation in concrete pavements at early age, the critical stress intensity factor, and the critical crack mouth opening displacement. And obviously those two are the main parameters of the fracture mechanics parameters, and they are used to identify the crack initiation and the stiffness degradation, especially the compliance factor that is associated with the loading and the crack propagation at the vicinity of a crack tip in the concrete pavement. The parameters that are taken into consideration in this study is, in fact, this study is a portion of a bigger study. The bigger study took into consideration the age of the concrete mixes, different mix designs, and different amount of fibers and different types of fibers. Age of the concrete mixes can range between 9 hours, 12 hours, 13 hours, 1 day, up to 28 days, as you can see up here. The types of the fibers, we use two different types of fibers, the WR Grace Strux 9040, which is very popular, and the master fiber noted as F2 and F1, as you can see in here, as I'm going to go over the other slides, and the amount of fibers. Other parameters were taken into different studies, such as the strength, the maturity, the effect. Different types of combinations were taken. In this slide, I'm going to just only cover the parameters that were taken for the fracture mechanics study. The PV mixes and the fresh properties of the mixes conducted. So we conducted 3 different types of mixes: the PV mixes, the pavement mixes for IDOT, and the patches mixes, which are PP1 and PP2. And the PV mixes were divided into PV without fibers and with fibers. So when we say PV, it's without fibers. The water to cement ratio is 0.42. PV F1 stands for Strux 9040, and it varied between 4 pounds, 6 pounds, and 8 pounds. And the Mac matrix fibers noted as PVF2. In case of PV, we only considered the 4 pounds, and that was just an additional investigation that we wanted to see. For the patches mixes, PP1 and PP2, we also took into consideration the effect of Strux 9040 fibers at 4 pounds per yard cube, and PP2F1 Strux 9040 also at 4 pounds. And you can notice here that the water to cement ratio in the PP2 case is smaller, as a higher strength is expected or is required at the time of opening to traffic. The curing test methods in this study, we considered the room temperature under 100% humidity. In different studies, we also took into consideration, as you'll see in the next presentation, so the study was actually divided between normal room temperature and cold temperature to simulate also opening to traffic at early age in different weather conditions such as cold condition and its effect on different parameters such as maturity and other variables. And the testing machines that were used, we used a simple Instron machine, which is a servo loop, closed loop machine with 50,000 pounds capacity of the load cell. And the data was collected on a separate data logger. And for the strength results, we used a normal Tinius-Olsen machine with 400,000 pounds capacity to measure the compressive strength and the flexural strength. This is the moisture room that we used. The special system was applied to maintain 73 degrees room temperature and a humidity of 100%. Similar thing here, that was a backup, additional way of curing. Also a heating tank with full immersion in water. The significance of the fracture mechanics is to provide indication of the effect of early opening to traffic and age on the toughness and stiffness degradation and crack growth in PCC pavement. And also we need to study the pre-cracking, cracking, and post-cracking behavior due to the tension softening curves after performing the load CMOD curves. The parameters that are going to be investigated are the stress intensity factor, which is an indication of the stress variation at the vicinity of the crack tip, and the critical crack tip mouth opening displacement, the CMOD, defined as the crack tip opening displacement at the original notch tip. The procedure for the testing, we prepared 3 by 4 by 16 beams, notched as per the RILEM recommendations at 4/3, at depth of the specimen divided by 3, so it's equivalent to 1.33. And the load cell of 1.8 kips for high sensitivity was used because these samples are notched and they do not take higher loads to initiate the crack. So we decided not to use a 50,000 pounds load cell because it has lower sensitivity. So a higher sensitivity load cell was used. And the CMOD gauge clip was used to control the feedback signals. A CMOD gauge was used to control the machine. So I'm going to show it in a picture in a little bit. So the CMOD clip was attached at the bottom of the beam, and while we load, the fixed CMOD rate was used to control the machine. So the machine was controlled by the CMOD clip, not the opposite. And the machine will automatically control the loading based on the requirement of the CMOD on a fixed rate, as I show you in one picture here. The rate was 0.0005, which is very slow loading, CMOD loading, not displacement loading. For the first cycle, which was designed to be around 5 minutes per cycle. And then for the rest of the cycles, after the crack initiated, we did not have to go as slow, so we doubled it for the rest of the cycles. A total of 10 cycles of loading and unloading, loading and unloading. We kept on doing it, and after that, the specimen was taken to failure. The reason we need to do that is to control the crack propagation as we go in the testing to be able to calculate all those fracture mechanics parameters. The notch was initiated using steel molds with plexiglass notch in here, 5 millimeter thick. And this is the machine that I was talking about. So this is the CMOD clip gauge attached here at the bottom of the beam, and an LVDT at the same level in the transverse direction was also attached only for the case when we have fibers. So for fibrous concrete, because it takes much more opening, crack mouth opening displacement, the CMOD gauge can go out of range. So we attached this LVDT as a backup. At the point where the CMOD goes out of range, the LVDT will pick up and we'll continue. We have extended data after the range of the CMOD. The range of the CMOD is around 10 millimeters. So after more than 10 millimeters, in fact, the ones with fibers, as you will see later, it will go up to 25 millimeters of crack mouth opening displacement. However, the ones without fibers, it will split into 2 pieces at around 1 millimeter. So this CMOD gauge controls the loading of the machine, and it's 1-point loading here, and another representation here, and for the shape of the failed surface. And this is the setup that I was talking about. It was taken from Shah 1990. Load P with supported span S, and the thickness of the loading clips was taken into account. These loading clips here, if you see them, were glued using epoxy, and the CMOD clip gauge was attached in the middle so that when you apply the load, it will open at the bottom, and then the CMOD gauge will pick up how much you have opening. All these parameters were taken into consideration, and the initial crack tip notch, the initial notch length as A0 was also taken into account. This is a typical loading and unloading scenario for every sample. So if you consider all the cases, we have with fibers, without fibers at 9, 12, 13, 1 day, 2 days, 3 days, 7 days, 14, and 28, with and without fibers for all the mixed designs. And with the fibers normally take much longer time, because without fibers it will split in half at around 1 millimeter, which is 0.004 inches, but the ones with fibers take up to 1 hour of loading, because the rate of load, 1 hour and sometimes 1 hour and a half, the rate of loading is too slow. So these are the equations from the literature used to calculate the parameters. The purpose is to equate the compliance factor with the unloading compliance and the loading compliance obtained from the CMOD, as you see in here. Once you equate them, you will have a critical stable crack growth. You will equate the E, the modulus of elasticity of the unloading, and the modulus of elasticity of the loading, and then after that you will be able to calculate the critical crack mouth opening displacement and the stress intensity factor. Typical values for the PV without fibers, as you can see, they fail and they stop at around 1 millimeter here, which is 0.04. And another observation is, as we increase the age from 9 hours up to 28 days, the maximum peak load will increase. But at some point around here, after we pass the 3 days, the gain in the peak load strength is less significant than the initial gain, from 9 to 3 days. Similar observation was seen with fibers. However, the failure, the fracture toughness obtained with fibers was much higher. I'm here only representing up to 1 millimeter, so for you to be able to see here in this zone. But if we go more to the max, some of them, they even fail beyond the 25, which is beyond the capacity of the gauge clip, the CMOD clip, and the LVDT. Observations here, the difference between the Strux 9040 and the Mac matrix fibers, in reality they didn't show. They showed very slight difference in between them. Only the very slight higher value at early CMOD values was registered by the Mac matrix fiber, but in general we can say that their behavior is almost the same. The highest fracture toughness value was obtained by the 8 pounds of fibers of Strux 9040, which showed the best behavior out of all of them. Similar observation here at later age. This one was at 24 hours, as you can see in here. Almost the same observation at 28 days. Always the 8 pounds was outperforming all of them. The values for the stress intensity factor, also the variation of the stress intensity factor was very consistent for all the PV mixes, with very high gain at around 3 days. And similarly for the CMOD values at around 3 days, around 70% or even more, 75% was obtained in the first 3 days. For the PP1 and PP2 mixes, almost similar observation. I'm just going over here the results for you to can see it, but in reality it's very similar. But because of the lower water to cement ratio or higher amount of cement, the maximum values was actually obtained in less than 3 days, in around 2 days for PP1 and 1 day for the PP2, because it's higher amount of cement. As you can see here, also very consistent behavior for PP1, F1, and PP1, which is the patch 1 with and without fibers, and similarly with the patch 2 with and without fibers. As a general conclusion, because I'm running out of time, most of the results were obtained before or at 3 days of concrete age, especially for the critical crack mouth opening displacement and the stress intensity factor. And the difference in the fibers was not really a significant value between the type of the fibers. However, the amount of fibers played a big role, and there was a big difference between without fibers and with fibers, and big difference between with fibers of 4 pounds and 8 pounds. The 8 pounds outperformed almost all the expectations. Thank you for listening. I don't know if I still have time to answer any questions.